Now, as we start Chapter 8, Section 1, we're going to be studying quadratic equations. Now, so far, when we had a quadratic equation, the only way we had to solve it was by putting it into standard form and then factoring it. In this chapter, we're going to see a number of various methods shown, including the principle of square roots, completing the square, and then we have a couple of problems, word problems, that we'll be doing toward the end. But let's continue and start looking at solving some of these answers or examples. So here's our first one. A squared equals 81. If in the past we had to do that, we would then change it to x squared, transpose the 81, and then equal it to 0, in a sense, putting it into standard form of the quadratic equation. There is no middle term here. Now, we see this is the difference of perfect squares, which will factor into its conjugates. So we have as an answer here x equals -9, and here x equals 9. So we get two answers. It is a quadratic equation to the second degree, and we need two answers, and we got two answers. Now, as we use the principle of square roots from Chapter 7, we know we can take the square root of x squared. That will give us x, and the square root of 81, that will give us a 9. But we're only getting one of the answers. So to ensure that we always get two answers, since we have a -9 and a +9, we add the symbol plus or -9 throughout the rest of our work. When we take the square root of something, we then say plus or minus the square root of the other side, ensuring that we get two answers. All right, let's set this one up. It's 4x squared equals 28. Now we want to isolate the x squared. So we're going to divide both sides by 4. We get x squared equals 7. Now we're going to take the square root of this side, and then using our new technique, plus or minus the square root of 7 is our answer. Now notice this wouldn't factor well, and so using the principle of square roots is the way to go for something like this. Now for something like this one, we want to divide everything by a -3. So this becomes now x squared, a positive x squared. We're going to transpose this to the other side, where on the other side it becomes a positive, on the other side it's going to become a -5/3. Now I'm going to take a step back there, because what I'm going to do is follow my own advice, move that over to the other side first to get a -5 on the other side. Now we're going to divide everything by a -3. That's better. So I now get x squared equals 5/3. Now I'm taking the square root of this side plus or minus the square root of that side. But I get, in a sense, a 3 under the radical. So this would be x equals plus or minus the square root of 5 over the square root of 3. And here's where our rationalizing the denominator comes in. I'm allowed to multiply anything by 1. So this would then be x equals plus or minus the square root of 15 over 3. And there we get the answer. Yes. Again, isolate the x term first. Then that'll work. In fact, if that was a negative on this side, on that side it would have become a positive. So we could have done it the other way too, but this way is better. Okay, now let's do this one here. This is 16 x squared equals a -49. Now we're going to divide both sides by 16. And we're going to take the square root of this side, which is now just x, which will become x, and then plus or minus the square root of this side. Well, keep in mind that this now becomes an imaginary number, and the square root of a -49 is plus or minus 7i, and the square root of 16 is 4. So x is equal to plus or minus 7i over 4. And again, if I'm going too fast, just pause the tape and we'll review. All right, letter E now. Now, letter E is sort of interesting. Let me write it up here for you. It's x squared plus 4x plus 4 equals 10. Notice, what is this? This is a perfect square trinomial that will factor into x plus 2, the quantity squared, equals 10. We have converted a trinomial into a binomial that's squared. Now, can we use that same technique, the principle of square roots? And the answer is yes. So we take the square root of this side, it just becomes the radicand, and plus or minus the square root of 10. So to complete our solution, we want to solve for x. We just transpose the 2, changing its sign, -2 plus or minus the square root of 10 is our solution for what x is in this particular equation. Now, as we go from this method, taking the square root of something squared, to taking the square root of a binomial that is squared. This is leading us into a topic that we mentioned up there, which was called completing the square. So that's where we're moving with this. All right. We have one more example to do here. And it's x plus 4, the quantity squared, is going to equal 5. So this is a binomial that's squared, and we're saying it equals 5. So can we use the technique of the principle of square roots? And the answer is yes. We take the square root of this, it just becomes the radicand, and then plus or minus the square root of 5. And we then just transpose the 4 plus or minus the square root of 5 is our answer. And what we're going to start shooting for is get what's on this side to be a perfect square trinomial that will factor into a binomial square so we can use this technique. Okay, that's where we're going with this. So we'll raise it up. And now we want to look at something. Now here we have ax squared plus bx plus c. This is the standard form of the quadratic expression. Now what we want to do is have this in the form of a perfect square trinomial that will factor into the form of a plus something squared. And that's what we did a little bit in one of the examples above. So what we want to do is we always want this a here to be a 1. So I'm going to erase this because that's going to be a 1. And then we still want to have that to be a perfect square trinomial. So how did we get that? And if you recall, we squared this term to give us this term. In fact, I could make that an x here. We squared this term to make this term. Now, how did we get our b term? This is going to be referred as our b term. It's the coefficient of what is with the x to the first. That's our b term. Now, we got that by multiplying these two and doubling it. So this would have been like x squared plus 2b, 2x I should say, got carried away there. We had to double it, 2x, and then we squared this term to get our c term, and that was like a 1. So this is a perfect square trinomial that when we factored it became a binomial squared. And when we expanded it became this. Okay. So this is what they're asking us to do here. So this is x squared plus bx plus c. Now, what is in the b spot here? Well, what is in the b spot is 10. Well, how did we get that 10? We multiplied this and doubled it. So b represents, as a 10 here, the doubling of something. So if 10 is the doubling of something, how do we get half of it? Well, I kind of gave that away. We have to take half of it. So what is half of 10? Half of 10 is 5. So that's what we're going to put here. And I'm going to suggest that we do it underneath like this. And they're doing it over here. That's fine. But as we work it, we're going to do it like this. So we got our 10, and we get an x here. This goes here. The plus goes right there. We got our 10 by multiplying whatever is here and then doubling it. Well, to find what was there, if we doubled it, we have to take half of 10. What is half of 10? It's 5. And that's what we put here. Now, we then want to take our binomial, and how do we get our C term? This is what the C term is. We get the C term by squaring this. And then we factor it into this, factor it into this. So these are the answers. The C term is 25, and the missing binomial term would be half of our B term, which is 5. Okay, now again, I'm going to suggest you want to do this like this. Now they're just putting it here to make it a little easier. I'm putting it here because this is the way we're going to work it. So our x term goes here as x. Our sign is negative. We now want to take what of our b term up here? And the answer is half of it. So the simplest way is just take the 9 and take half of it, and it becomes 9 halves. Now another way of doing it is 9 times 1/2, which just is 9 halves. Dividing it by 2 comes out the same. Now, so over here we're going to put 9 halves. Now, what do we do to this term to get our C term? Our C term here. We have to square that. So that's going to be 81/4. Now if we factored this, it would factor into this. But the easy way before you factor it is just put your parentheses there, put the x there, the negative sign there, and take half of your B term right there. Perfect. Now, this process that we're doing has a name. Let's see if we can get a math star out there. What is the name of this process that we are doing here? Think about it for a moment. And if you said completing the square, you are correct, because we are completing the perfect square trinomial here by figuring out if we had these two, what would we have to put here that we could factor that into a binomial squared? And the process of doing what we just did there is called completing the square. Okay? Now, there is a recipe for that, and I'm going to keep this up there so we can refer back to it, but I want to erase this down here because we'll use this space to do it. Now, again, take some careful notes because I'm going to show you the process. X squared minus 6x minus 8 is what we have. Now, will this factor? If this were a positive 8, it would, but it's a negative 8, so this does not factor. But they've asked us to solve this quadratic equation by completing the square. So here's the recipe. We want to take our C term, which is our C term right there, and transpose it to this other side here. On the other side, it becomes a positive 8. And I'm going to take my 0 out of there now. And this is now on the other side. Now notice, everything is the same. We haven't changed anything. We just rearrange things a little. Now, we want to make this, which is the first part of the quadratic expression, into a perfect square trinomial by adding some term here. Now, I'm going to strongly suggest that once it's like this, you then put a parenthesis and something squared, because you're going to force this to become a binomial square. Now, what did we say we do? Well, we take our x and put that x right there. We take our negative sign and put that right there. Now, we look at our b term. Our b term is a negative 6. What do we have to do to that b term? And we take half of it. What is half of a negative 6? A negative 3. Now, what do I need to do to complete the square? Now that I know what this term is, I have to square it to get a 9. Now I have a perfect square trinomial. But I don't have an equation anymore. Does anyone know why? Because I added a 9 to this side, but I didn't add the 9 to the other side. Now I have an equation. So I factored this into this. I add these together and I get 17. Now I have a binomial squared equals 17. I now use the principle of square roots to take the square root of this side and then plus or minus the square root of that side. So I then get x minus 3 equals plus or minus the square root of 17. And now I just transpose that, and I get x equals 3 plus or minus the square root of 17. And I have solved this equation by completing the square. Now, the marvel of these YouTube videos is you can go back and watch this whole process again. But I don't have to repeat it because you can physically do that. And we're going to go on to letter D. Now, in letter D, I'm going to write it out for you. X squared plus 3x. Now, what I'm going to do with this negative 5, I'm going to move it over to the other side already. This is my C term. That's the first thing I do. Move it over to the other side. And I get a positive 5 there. Now, I want to complete the square. So I'm going to use this technique. My x goes there. The positive goes there. I have to take half of the 3. Half of the 3 is 3/2. Now, I'm going to be able to square this to get my C term, which is 9/4. It's not an equation anymore. Why not? Because I have to add 9/4 to both sides. Okay, now notice I'm not able to add these because they are not the same denominator. So I have to take 5/1 and convert it to something that has a denominator of 4. Well, I'm going to multiply that by 4, multiply that by 4. 4/4 is 1, so this becomes 20/4 is what this 5 is. So with the magic of eraser, I'm going to make that 20/4. In fact, I'm going to add those together and get what? 29/4. So I've saved myself a little room by doing that. Okay. Now, I have this equals 29/4. I take the square root of that, and I take plus or minus the square root of that. Now notice 4 is a perfect square. So this then becomes x plus 3/2 equals plus or minus the square root of 29/2. When I take the square root of 4, I get that 2. Now I just transpose that, and I get x equals a negative 3/2 plus or minus the square root of 29/2. And how did I do it? I did it by completing the square. Wow. Now, to use the completing the square for this one, it's going to be quite tedious, and it starts off like this. I'm not going to take the time to do it all because it takes too long. We have to divide everything by 2, and then this then becomes x squared plus 9/2 x, and then I'm going to move this to the other side as a 3/2. And let me do it anyway. Again, there's another way in the next section that if I came across something like this, I wouldn't use completing the square. They're asking you to do it. It can be done, but we're going to use what we call the quadratic formula, which is in our next lesson. So here, the 2's cancel out, and we get x squared. This becomes 9/2 x, and we take our negative 3/2 to the other side as a positive 3/2. We then take our x, put it there, and what is 1/2 of 9/2? Well, it's 9/4. Okay, now I have to square this and get 81/16. I kind of ran out of room there. Add it to this side, add it to this side. So I did it down here. Now, 3/2 is what I have there. I'm adding 81/16 to it. Well, I have to take my 3/2, convert it to a fraction with a like denominator. So I multiply to 2 by 8, the 3 by 8, I get 24/16 is 3/2. I can now add it. I get 105/16, which is what I have right over here, 105/16. I then take the square root of this side, which gives me this, plus or minus the square root of that. Now, 16 is a perfect square. So that's going to give me 4 in the denominator, and then in the numerator, 105, which I take the square root of course. I take my positive 9/4, bring it over as a negative 9/4, and there's the answer. Now I did this very quickly because again, I wouldn't use completing the square to do this. It's just too tedious, too many fractions. All right, and we're running the taper already 30 minutes, but a lot of stuff going on here. Now, what I'm going to do for a moment, I'm going to switch out. I'm going to close this, and I'm going to go to the Pearson textbook, because this is what the textbook looks like. And here they're giving us a formula, or we need a formula, and they're not telling us what it is. Where is that formula? Well, it's in the textbook. It's A equals P times 1 plus R raised to the T power. It's the compound interest formula. So again, in our little work here, it doesn't give us everything. It's in our textbook. I just wanted you to see that. So going back to where we are, right there, they want us to solve this example here. Well, for this example, we need the formula. That's why the textbook is important. We have A equals P times 1 plus R to the T power. And they want us to find here what is the rate, this R inside the formula. Well, they give us the information, so we substitute. 3630 is our new amount. Our initial principal was 3,000 times 1 plus R. We didn't know what R is, but we know our time is 2 years. So how do we solve that? Well, we want to isolate where the R is. So we're going to divide both sides by 3,000. And again, this is your recipe if you have any like that. So this cancels out, and we then get, let me just erase this then to save a little room. We get that. Now, how do we get our R by itself here? Well, we have to take the square root of this, and that will give us 1 plus R. Well, the nice thing about a calculator is you just put this information into your calculator and take the square root of that. Okay? And what do you get? Well, if we first do this division, we get 1.21. And then if we take the square root of this, we get 1.1. Now notice it was a plus or minus. And for interest rate, we don't use the minuses, so we can kind of skip that. How do we get then R? Well, we're going to subtract 1 from both sides. And when we do that, that gives us 0.1. Now, for rate, this is a decimal. We want a percentage. So 0.1, to change it to a percent, we have to add a 0 and then move the decimal place over 2 places and add the percent sign. And for this, in order to get it to grow to this in 2 years, we'd have to have a 10% interest rate. Okay. Now for this last one, Here we have 16t squared. S is where it starts from, 740 feet. We're going to divide both sides by 16. We get t squared equals the plus or minus, and we don't use the minus here. Keeping in mind it's there, but we don't use it. The square root of that, which comes out to be 6.8. So our time, we get rid of this, t is 6.8, and that's how it's done. And we just ran under 36 minutes. Lots of stuff. Again, I strongly recommend you to look at the textbook. I have a video in which I go over all of the things in the textbook.